In this video, we are going to talk about the solid principles of OOP, or Object-Oriented Programming. Now, the history of solid principles goes back to March of 1995. They were originally concepts by Robert Martin, also known as Uncle Bob. These started as a variety of writings and blog posts, and then they later became the foundation of Martin's book called Agile Software Development: Principles, Patterns, and Practices. And then Michael Feathers is actually credited with coining the acronym SOLID. Now, what is SOLID? Let's take a closer look at that. These are actually 5 principles. We have the single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and then finally dependency inversion principle. So single responsibility principle. So just because you can doesn't mean you should. One of my favorite sayings there. So in the single responsibility principle, every class should have a single responsibility. There should never be more than one reason for a class to change. Your classes should be small. Ideally, a good guideline to go by is no more than a screen full of code. Avoid, air quotes, God classes, things that do everything. Split big classes into smaller classes. I have seen Java methods that are over 2,000 lines, and the developers swore that they tested fine, and these were complex. So if you have a method that's 2,000 lines of code, something's wrong. So don't be that developer making these massive methods. A 2,000 line method is absolutely impossible to unit test properly. You want small, digestible chunks of code, basically, is what we're saying with a single responsibility principle. Next on the list is open-close principle. So here we're saying open chest surgery is not needed when putting on a coat. So for example here, in the open-close principle, we are saying that your classes should be open for extension, but closed for modification. You should be able to extend the class's behavior without modifying it. So here we want to be using private variables with getters and setters only when you need them. And a good habit here is be using abstract-based classes. So the principle here is designing your software in a way, your classes, that they can be extended for their use. Next is Liskov substitution principle. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. So this was actually founded by Barbara Liskov in 1998. So object-oriented programming goes back quite some time. Objects in a program would be replaceable with their instances of their subtypes without altering the correctness of the program. So here, if you violate this, violations will fail the ISA test. So if you remember some of your object-oriented programming principles, the foundations of using that as a test. A square is a rectangle. However, a rectangle is not a square. So very, very simple test there to follow that substitution principle. Next, we have the interface segregation principle. You want me to plug this in where? So this is a very important principle. Make fine-grained interfaces that are client-specific. Many client-specific interfaces are better than one general-purpose interface. You want to keep your components focused and minimize the dependencies between them. And then notice the relationship here to single responsibility principle. So you want to avoid God interfaces. And we already saw this a little bit in the course where I talked about the dependency injection of the Spring Framework, where we want to be using interfaces. So what this is saying is that we'll have interfaces that we're coding to allow us to use Spring Framework to change the behavior of the application by plugging in different components. So that's really the concept behind integration segregation principle. You want your components basically to be plug and play. So you don't want to overcomplicate them, but allow yourself the flexibility where you can swap things in and out. If you get something too complex, then you won't be able to have componentized software. Dependency inversion principle. Would you solder a lamp directly to the electrical wiring of the wall? No, of course not. You'd want to use a plug. So this principle is saying that abstraction should not depend upon the details, and details should not depend upon the abstractions. This is important, that higher level and lower level objects depend upon the same abstraction. This is much different than dependency injection. Easy to confuse the two. Dependency injection is how objects obtain dependent objects. This is saying that your abstractions should work together and not be tightly coupled. So you don't want to have something tightly coupled where the two objects are dependent upon each other. You want that abstraction. That abstraction should allow the objects to work independently, but also be like plug and play so you can move things in and out. Like think of a wall socket. A wall socket is going to accept a lamp, a radio, a TV. So it will accept different things, but through that air quotes of a socket interface. So in summary, the solid principles of OOP will lead you to write better quality code. Your code will be more testable and easier to maintain. A key theme throughout all these principles is to avoid tight coupling your code. So think about that 2,000 line method. That's just insane, to be honest with you. It's just a bunch of code. A lot of it would be unreachable from unit testing. So it's just a bad, very fragile piece of software. But at the same time, be pragmatic when you're following the solid principles. Every request path does not need its own controller class, so you can have a controller for products that is going to handle the save, update, delete operations. So the class does have a purpose in life. Technically would violate the single responsibility principle. But, like I'm saying, be pragmatic when we implement these. If your class does have 4 methods that are all related to a relatable object, that is perfectly fine. So, again, be pragmatic, but also follow these principles. You do want to have a purpose in life for the classes that you write, and the less coupling that you have between the classes, the more flexibility and more quality your code will be.